Okay, today we are continuing on with surface area. Last week we looked at the surface area of prisms and cylinders. Today we're looking at the surface area of pyramids and cones. And again, just like last week, we kind of do these together because they're basically the same thing. The only difference is the shape of the base. So let's go through some basic vocabulary to begin with. This top point up here is called the vertex. This guy that they're referring to here, smack down the middle, is the height. This length right here is called the base edge. And this guy right here is called the lateral edge. And again, as I said, same concept, we're looking for the surface area. And a couple different ways, just like we did last week, we'll show you how do you do it kind of on your own versus how do you do it using your formula sheet as well. So the lateral area of a regular pyramid is half the product of the perimeter and the slant height. And the slant height represents the height of the triangle. So if we go and look at that, that means we've got 1/2 P, and we use the letter L to denote slant height. So let's go ahead and write that out. L is equal to the slant height. And then to find the total surface area, we take the surface area of the lateral area and the base area. So again, let me just go grab your formula sheet just to show you where we're at on that formula sheet, because again, you'll get to use it for your quiz and for your test. So we're moving down to pyramid. Here's that lateral area, 1/2 P times L. And here's the surface area, 1/2 PL times big B. And you might be asking, why is it big B here and 2 big B here? Well, in a prism, you have 2 bases, the top and the bottom. In a pyramid, you only have 1 base. So let's go ahead and fill that in. We've got 1/2 PL plus big B, and again, big B is the same thing. It is the base area. So let's start by looking at this one, and as always, just to continue with vocabulary, let's think about what is the name of this pyramid right here. And remember, we classify it according to the base. And this particular base, here is your base. So that would be a square pyramid. So, and we're just going to change this. Let's go and find the lateral area and the surface area. And we'll use our formula on one, and then maybe on another one we'll just think about the net instead. Let's go ahead and use the formula on this one. So first thing I'm going to do is go ahead and write down that formula. The lateral area is 1/2 PL. And remember that P stands for the perimeter of the base. So I'm looking for the distance all the way around that square, which would be 4 times 7.5. And then I'm multiplying it by the slant height. Again, the slant height is the height of one of those triangles of the lateral faces of that pyramid, which in this case they gave us to be 12. So let's go ahead and grab your calculator and type that in. And we end up with 180 feet squared. Now remember, if we're looking for the total surface area, that's the lateral area, which would be all of those triangular sides, plus big B, which is the area of the base. And remember, we said the shape of the base is a square, so think about how would we go and find the area of that base. And because both sides are the same, that would just be 7.5 times 7.5. and we end up with 56.25. And then we'll go ahead and finish it up and find the total surface area, which is 236.25. And that would be feet squared. Okay, let's go take a look at another one, but again, some of you might be a little bit more visual or concrete, so instead of using the formula, we could go ahead and, I guess, kind of sketch it out. So again, we've got a square pyramid, so let's go ahead and sketch that out. And again, we're looking for the surface area. It says it has a base edge of 10. That means each of these are 10. And then it tells us the overall height, which would be smack down the middle, would be 8. Okay, so first thing, let's look at what would the surface area of the base be. Again, we can see it's a square, so that would be 10 times 10. And then with the lateral area, we're looking for the area of each one of those triangles. Well, if you notice, each one of those triangles are the same and you have 4 of them. So we could do 4 times 1/2 base times height. The base of one of those triangles is 10, which is here. Now the tricky part, what we don't have is this slant height. We have the overall height, but not that slant height. So if I can, let me go ahead and pull out the information that we have. So we have the overall height is 8. We have the distance from here to here would be 5, and we're looking for that slant height. So what would you use to find that slant height? We would use Pythagorean's theorem. So we have L squared equals 8 squared plus 5 squared. 64 and 25. We end up with L is equal to the square root of 89. So let's go ahead and type that in our calculator as well. So for the lateral area, I'm coming up with 188.7. And then we'll add it to that 100. We get 288.7 centimeters squared. Okay, now let's move on to the cone. And as I said, the cone is similar to the pyramid. The only difference is the cone's base is a circle instead of a square or a rectangle, whatever it was on the others. So first thing, let's go look at some vocabulary. Again, notice L is still here. It's the same thing it was on the front. It is the slant height. This guy right here is the overall height. And then down here, they're pointing to the fact that you're looking for that base. So that would be a circular base, which in our case also would correspond with the circumference. So again, let's go take a look at the formulas. If you look at your formula sheet, again, back down under cones, we are looking at the lateral area is 1/2 PL, and we've got the surface area is 1/2 RL plus pi r squared. So let's go take a look at how this formula is going to work. So the lateral area, if you think about what it was on the pyramid, it was 1/2 PL, but if I go ahead and substitute in the perimeter, which is just the fancy word for the circumference of the circle, if you notice those 2 and 1/2 cancels out, that's how they end up with 1/2 RL. And big B we know is the area of the base, which in this case is a circle, and we know the formula for area of a circle is pi r squared. So let's go take a look at number 3. All they want us to do is find the lateral area. So if you look at your formula sheet for cone, it says the lateral area is equal to pi RL. So we've got the radius, which is 4. Now what we don't have is the slant height. So think about how would we go and find that slant height? what formula would you use, and ultimately what do you end up with for the slant height? So we can go and use Pythagorean's theorem. We end up with L squared is 25, so we know the slant height is equal to 5. Finally, finishing that up, we end up with a lateral area of 20 pi. All right, let's go on to the next one. We're looking for the surface area of the cone. Again, look at your formula sheet. It says pi RL plus pi R squared. Okay, we don't know the radius, so let's leave that blank for the moment. We do have that slant height. It's right here. It is 18. And again, we need the radius squared, which again, we don't have. So again, we got to go think about how we're going to go and find that radius. So we can go and set up using Pythagorean's theorem and ultimately figuring out what that radius is. So we've got radical 180 squared there, and we have radical 180 there. And I'm just going to go ahead and type it in and enter it to the nearest tenth. So here we go. We've got pi, the square root of 180 times 18 plus pi, square root of 180 squared, and that's it. And we end up with 1,324.2 centimeters squared. Okay, let's go look at the last one. It says that Leandra has paper cones to cover her plants in the early spring. So in the spring, if there's going to be a frost, then oftentimes people will go out and they will cover their flowers with sheets or something like this. In this particular case, they want us to cover it with a cone. So let me show you kind of a visual. So they're covering it with a cone. So if you think about why are we not finding the total area, that's because the plant is in the ground. I don't have a space to fill in right there. So all I want is that lateral area. So again, let's go back and look at your formula for lateral area. It says pi RL. We have a diameter of 1, which means the radius would be half of that, which is 0.5. And we have the overall height, which is 1.5. So again, let's come over here. We've got this length is 0.5. This is 1.5. We want to go again and find that slant height. And I'm coming up with the square root of 2.5, so I think I'll just leave it like that for just the moment. Again, I just used Pythagorean's theorem, so we ended up with radical 2.5. Finally, let's go ahead and plug all of that in and see what we get. And we end up with 2.5, and that would be feet squared. Okay, as always, if you have any questions or concerns, post those on the discussion board and I will be checking those throughout the day.